As an example of the 7 steps, let us consider the problem of finding the intersection of two rectangles. We'll deal with only rectangles whose edges are horizontal and vertical, making things much simpler. To do this problem, you need a bit of domain knowledge, such as what a rectangle is, which you may recall is a four-sided shape with adjacent sides at right angles to each other, and what it means to find the intersection of two rectangles, which is finding the area that is inside both rectangles. Step 1 is to do an instance of the problem yourself. We've started here with a blank Cartesian plane on which we can precisely draw rectangles. Now I've picked one rectangle from -4, 1 to 8, 6. Next, I've picked another rectangle which goes from 1, -1 to 4, 7. The intersection of these two rectangles is highlighted in green, which we can see goes from 1, 1 to 4, 6. We'd like to write down exactly what we did to figure this out, but our inclination might be to just say that we looked at the answer in our drawing. This happens frequently. You just know what you did, but have trouble thinking through it step by step. When this happens, a good idea is to work through another instance and try to think about what you're doing. Here, we've taken away the grid lines so that we can't just read off the coordinates from our final drawing. For my first rectangle, I choose -2, 1 to 6, 3. Then I choose -1, -1 to 4, 4 for my second rectangle. The intersection here is in green, but what are the coordinates of its corners? This rectangle goes from -1, 1 to 4, 3. Now, let us write down exactly what we did. The first question we should answer here is, how did we represent a rectangle as numbers? The answer is that a rectangle is 4 integers, left, bottom, right, and top. Next, we need to think about what steps we took to come up with this answer. First, I figured out that the left edge has an x-coordinate of -1. Next, I figured out that the bottom edge has a y-coordinate of 1. Then I figured out that the right edge has an x-coordinate of 4. And finally, I figured out that the top edge has a y-coordinate of 3. My answer was the rectangle -1, 1 to 4, 3. Okay, now we are ready to generalize these steps to any pair of rectangles. Why did we pick -1 for the left side of the answer? We might think that this was because it was the second rectangle's left. But will it always be the second rectangle's left? No, it was only the second rectangle's left this time because the second rectangle's left is larger than the first rectangle's left. More generally, it will be the maximum of the two rectangles' left sides. What if we had not caught this subtlety now? We should catch it later, either in step 4 when we test our algorithm by hand, or in step 6 when we run test cases on our code. If we catch it later, we would come back to step 3, correct the algorithm, and redo later steps. So generally, our answer's left side will be the max of the two input rectangles' left sides. What about the bottom? Why was it 1? Again, we might think that it was because it was the first rectangle's bottom, but this runs into the same pitfall that we just discussed. It is actually the larger of the two rectangles' bottoms. We then go through similar thinking for the right, which is the minimum, not the maximum, of the two rectangles' right sides. Lastly, the top is the minimum of the two input rectangles' tops. Let's write that down a bit more explicitly as directions. First, we make a rectangle, which we will call ants, with the sides determined by the maximum or minimum of the input's rectangle sides as we just discussed. And then, the rectangle ants, which we just made, is our answer. Next, we should test our algorithm. It seems pretty straightforward, so what could possibly go wrong? For one thing, the only inputs that we used to construct it had the same general shape. R1 was wider than R2, and R2 was taller than R1. If we'd made any of the mistakes we just discussed in step 3, we would not have caught them yet. A slightly more subtle case exists that we have not yet accounted for. It is possible that the rectangles might not intersect. What does the algorithm produce in this case? What should it produce for this case? It really should produce no such answer, so we'll need for our algorithm to have some way to represent that the answer is no rectangle exists when it encounters that case.